So here are some rules to avoid over-constraint configurations when we are constraining a part. So let's say if you are constraining this part, which is a rectangular plate in yellow color, using these 4 points. Now these 4 constraints will be over-constraint. We need 3 points for exactly constraining 3 degrees of freedom in 2D. An additional point will become over-constraint. So no 4 constraints in a single plane should be allowed. 3 constraints maximum possible in one plane. So maximum number of points of contact in one plane should be 3 to exactly constrain. So this is rule number 1. Rule number 2 is that 3 constraints should not intersect. So as you can see, this is a triangle and these 3 points of contact will create a normal force which will all intersect. So the lines of action of the normal force of the points of contact should not intersect. So if we draw a normal line from this, it will be somewhere over here. If we draw a normal line from this, it will be here, and normal line over here will be like this. So all these 3 lines will intersect at the median of the triangle. So this will create an over constraint. So it is true for any shape which is having these 3 types of contacts which will be intersecting. So as you can see, this is a circular plate and it is contacted at this point, and this point. So if we draw line of action of the normal force, all 3 lines will intersect at one point. So in order to avoid over constraint, we need to avoid this kind of configuration. And the last rule is that no 2 constraints should be collinear. So let's say if you're having a rectangular plate like this and the points of contact are opposite to each other, then the lines of action of the normal forces which are acting will be collinear. They will be on the same line. So the normal forces which are impinged by the constraints will be on the same line. So no 2 constraints should be collinear. This is the third rule. So to summarize, the 3 rules are: no 4 constraints should be on the single plane. The maximum of 3 constraints should be in one plane. And no 3 constraints, no 3 points of contact should have normal forces intersecting at a point. And no 2 constraints, no 2 points of contact or no 2 lines of action of normal forces should be collinear on the same line. So these are generic rules of thumb for simple shapes to avoid over constraint in 2D. These rules can be applied when we are designing a part. Let's say a component has to fit inside another component or another assembly, and the position of that component should be such that it should be exactly constrained, not over constrained, not under constrained. So when we are designing for exact constraining a part inside another assembly, then these kind of rules will help us to avoid over constraint configurations and also helps in precise and accurate location of features.